Welcome to part 2 of Introduction to ECGs. As part of my school project, as I mentioned in part 1. And there's a quiz at the end of this video that covers part 1 and part 2. And I would advise that you watch part 1 in order to gain a better understanding of part 2. Okay. Abnormal PR interval. Try to recall what is the normal PR interval. Normal PR interval is from 120 to 200 milliseconds. And PR interval can either be prolonged or shortened. Remember, PR interval refers to the time it takes for the wave of depolarization to start at the SA node until it gets to the ventricles. So if it's taking longer for that wave of depolarization to reach the ventricles, then PR interval will be longer, and this can be caused by blocking conduction. We'll talk about this in a future session, the significance of prolonged PR interval. So looking at this diagram, from the start of the P wave to the start of the QRS complex, if you count the number of boxes, is about 8 or 9. Same there. So it's more than the normal range. So you will see there's prolonged PR interval there. Shortened PR interval is caused by when there's abnormally fast transmission of that wave of depolarization from the atrium to the ventricle, so it's going really quick. And this usually occurs like in a condition like Wolff-Parkinson-White syndrome, where apart from the normal circuit, you also have an additional wiring that connects the atrium to the ventricles directly. So you won't get that AV node delay because it's not present in that additional circuit. So the wave of depolarization will just travel from the atrium to the ventricle straight away. So that will lead to shortened PR interval. And from this diagram, it's not very clear, my apologies, but this is 2.5 from the start of the P wave to the start of the QRS interval is about 2.5, which is less than 3 small squares, and this is about 2.5 as well. So supraventricular rhythm, what does the QRS complex look like in supraventricular rhythm? Remember, supraventricular rhythm is when the wave of depolarization starts from the sinoatrial node, the atrium, or the atrioventricular node. The wave of depolarization ends up going through the bundle of E's or the bundle branches. So it reaches the ventricles normally. The ventricles are depolarized via the normal route because they pass through there, and QRS complex is normal, which means it's less than 120 milliseconds, which is less than 3 small squares. So this is what sinus rhythm looks like. So you can see it's less than the QRS complex is about 1 small square there. This one too, atrial rhythm, 1 small square throughout. Junctional rhythm as well, the QRS complex is normal because they are supraventricular, and is also another form of junctional rhythm. So QRS complex is less than 120. In this case, it's just about 40 milliseconds. So yeah. In ventricular rhythm, so when the wave of depolarization starts from a point in the ventricles, the wave of depolarization doesn't follow the normal route. It doesn't go through the bundle of E's or the bundle branches. The wave of depolarization goes through an abnormal route through the Purkinje fibers, and this abnormal route is slow, so that means it will take longer time for the wave of depolarization to spread across the ventricles. Longer duration means wider QRS complex, so you have a QRS complex greater than 120 milliseconds. If you look at this, these are QRS complexes. Yeah. If you look at that, you can see it's greater than 3 small squares. That's about 8 small squares throughout. And some of you might ask, why is there no T wave? There's no T wave because normally, usually when the ventricular depolarization is abnormal, ventricular repolarization tends to be abnormal as well. So in this case, you don't get T wave because it's abnormal. And as I mentioned earlier, no P waves because the wave of depolarization from there is not reaching the atrium. No atrial depolarization, so no P waves. Okay, so I'm just going to go over the causes of wide QRS complexes quickly. Some of the things I'll mention today, we'll actually talk about them in a future video. So bundle branch block is one of the causes. Bundle branch block is when one of these branches are blocked. So it could be right bundle branch block, left bundle branch block. So the wave of depolarization, let's say the right bundle branch is blocked. The wave of depolarization will come down, go to the left side. The left side will be depolarized normally, but because the right side is blocked, there will be no depolarization on the right side, and then the left depolarization will have to spread to the right side. That's an abnormal route, and because of that, you have a wide QRS complex because it's taking longer for this right side to be depolarized. So that's why you have wide QRS complex in bundle branch block. We'll talk about this in another video. Ventricular rhythm, I've already explained why you get wide QRS complex. And complete heart block. So in complete heart block, it's when you don't have the wave of depolarization going past the AV node. So that delay, no wave is going past that point. Or it could be because there's a block in the bundle of A's, or there's a complete bundle branch block, so the left and right are blocked. So that means none of the wave of depolarization is reaching the ventricles. Complete heart block is when no wave of depolarization is reaching the ventricles. So if no wave is reaching the ventricles end up producing their own wave of depolarization, and that's literally ventricular rhythm. And then abnormal route, which is slower, so wide QRS complex. And this is just a summary of all I've been talking about. Okay, to check rhythm, I'll be telling you how to check if a rhythm is regular or not. To check if rhythm is regular, you use the rhythm strip there. So the bottom of the page, the really long ones. These ones aren't long; they are like really short. But this one is quite long. That's one you use to check if the rhythm is regular or not. So what you do is get a piece of paper, yeah, then mark QRS complexes, mark them 1, 2, 3. So mark with a pencil. So when you've marked that, mark 3 points, then put the paper to the third one and see if the points match. If the points match, so they all match with the markings you did match with the QRS complexes. If they match, then it means the rhythm is regular. If they don't match, then the rhythm is irregular. So let's say the first one will be there, and then you have your QRS there, and then you have a QRS there. They are not matching, so that will be irregular. We'll do a quick exercise of this soon. So yeah. And rate. To calculate rate, this is a formula you use. So 1500 divided by the number of small squares between two R waves. And that's only if it's regular. If it's irregular, you do number of complexes on the rhythm strip times 6. Remember I said the rhythm strip runs for 10 seconds. So if it runs for 10 seconds, you are trying to calculate the heart rate, which is measured over 1 minute. 1 minute is 60 seconds. So if you already know what is in 10 seconds, just multiply by 6. That will make you know what is in 60 seconds. Each complex represents 1 bit, so the number of bits in 10 seconds times 6 will give you 60 seconds. So that's what you use to estimate for a regular rhythm. And bradycardia is when the pulse rate is less than 60, tachycardia is when it's greater than 100. So we have an ECG strip there. Now let's try to see the rhythm is regular or irregular, and afterwards try to calculate the rate. So put your piece of paper, mark 3 QRS complexes, 1, 2, 3. Now you have to slide the paper, so picking this point, so picking the last one, place the first mark in there, so slide your paper there. Now your paper is there, and check if they match, if the remaining QRS complexes match. If they do, in this case, that's regular. Okay, so it is a regular rhythm. Now for you to calculate the rate, pick 2 QRS complexes and count the number of small squares between them. So I tend to do 1, 2, 3, 4, that's 20. Then the extra small squares, 1, 2, that's 22. So we have 22 small squares between them. So using the formula 1500 divided by 22, you get the beat as 68 beats per minute. Yeah. So this is only when it's regular. Okay. Now this rhythm strip, we want to see if it's regular or irregular. Well, yeah, as I was saying, that can give you the speed. It tends to be on the ECG paper, so look at the speed of the ECG. Okay, so pick 3 QRS complexes, mark your points, 1, 2, 3. Now slide the paper, so you've picked that, slide the paper to this point and see if they match. You can see that they don't match, so no QRS complex is there, so that makes it irregular. So that's an irregular rhythm. So now how do you calculate the rate of an irregular rhythm? Remember I said you count the number of QRS complexes, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So count that and then multiply by 6. The reason you multiply by 6 is because this strip runs for 10 seconds and you are trying to find how many QRS complexes in 1 minute, which is 60 seconds. So 17 times 6 is 102 beats per minute. You can pause the video and do this quiz, and after this there's also one extra question. And then you have the answer afterwards. So pause the quiz. After you've answered it, you can look at the answers, which is on the next page. And this is a summary of all we've done today. So in summary, ECG speed is 25 millimeter per second, and these just the values for big squares and small squares. Normal PR interval is 120 to 200 milliseconds, that's 3 to 5 small squares. Normal QRS interval is less than 120 milliseconds. And then this is a sequential approach to ECG interpretation. Just calculate the rate and rhythm, then look at the cardiac axis, then afterward follow the wave of the ECG to decide to interpret. And rhythm is where the part of the heart where the wave of depolarization starts from. And rhythm can be classified into supraventricular and ventricular rhythms. Supraventricular rhythm is divided into sinus, atrial, and junctional rhythms. And P wave represents atrial depolarization. So whenever you get atrial depolarizing, you get P wave on the ECG. QRS complex represents ventricular depolarization. So if the depolarization occurs through the normal route, like in supraventricular rhythm, then you have normal QRS complex. So it's normal, it's less than 120 milliseconds. But if the wave of depolarization occurs through an abnormal route, which is slower, then you get a wide QRS complex, because our wave of depolarization takes longer time to spread. So you can get that in bundle branch block, ventricular rhythm, and complete heart block. And if the rhythm is regular, you check with the paper, map it out. If it's regular, then use this formula. And if it's irregular, so the markings don't match, then use this formula: number of complexes on rhythm strip times 10. The reason for this formula is because rhythm strip runs for 10 seconds, count the number of complexes on it, and if you multiply by 6, you'll be finding how much you have in 60 seconds. Thank you for watching the video, and this is where I got all my information from. And hope you watch the next video. It will be on other topics on ECG.